So we're still in unit 7. And we're going to be looking at product and quotient to a power rule. So these are going to kind of be intertwined together. All right, it's not going to be like I'm going to say, hey, this is the quotient one, this is the product one. They're all going to be kind of mixed in together. So the one way that I like to remember these and kind of help me these is think about these as reverse distributive property. All right, so we know distributive property, you get your parentheses, and that's everything on the outside times everything on the inside. Okay, so it looks something like this. Okay, so we draw blanks. I have like x to the -3 plus y. All right, everything on the outside, everything to the inside. Okay, but when we have our exponent rules, quotient to a power, product to a power, the way these are going to look, we'll start with the product one. Let's say if I have 3x squared y to the 4th z raised to the 3rd power. Okay, so it's called product to a power because everything on the inside is being multiplied. All right, when you have numbers and variables side by side, that means to multiply. For some reason, that's something that confuses a lot of students. Like if we have 3x, okay? A lot of us view this as just 3x and we don't know what it means, but it's 3 times x, okay? And the reason that I say that, somebody's like, well, I know that, I get it. But if I say, okay, what's the solution to this if x is 5? You know, how many times for the 7 years I've been teaching, I get this answer? 35, Mr. Reed, 35. No, it's multiplication, okay? So we got to understand that when things are side by side, it means to multiply. So when I say reverse distributive property, the way we solve these is we don't go from the front end, we go from the back. So this will go here, it'll go to everything inside of here, kind of like reverse distributive property. So when you have your power to a power rule, you multiply those exponents. So what we end up with is this 3 to the 1st power, 3 to the 1 times 3, x to the 2 times 3, y to the 4 times 3, and z to the 1 times 3. So you're multiplying that exponent by all the exponents on the inside of your parentheses, okay? And then from there, you can just simplify. So 1 times 3 is going to be 3. So we got 3 to the 3rd power, x to the 6th power, y to the 12th, z to the 3rd. And that's your final answer. Okay. So it's everything on the outside times everything on the inside, but kind of in reverse. All right. So you're just multiplying those exponents to everything. Now, some of you are looking at this and thinking this is really easy, like, okay, that's fine. But the thing that confuses a lot of people here is when you have a number and a variable by itself, understanding that those are to the 1st power. Okay? Because I've had people in the past say 3 times 3 is 9. All right. So understand that's the power of 1, and when you multiply those. Now again, here you could have, sometimes you'll see an answer where this is simplified, that'll be 27. You'll say 27, x to the 6, y to 12, z to the 3rd. Okay. So you'll have that sometimes, but understanding how to see those different answers. Let's look at a division. Let's say we have, let's see, 2 x to the 4th over y to the -3rd raised to the 7th power. So with division, it's the same thing, okay? And what can be confusing about division is this 2x to the fourth, viewing that as 2x to the fourth is one thing, but it's 2 times x to the fourth, all right? Which means this 7 needs to go to the 2, it needs to go to the x, and it needs to go to the y, okay? It has to go to all of those. In the past, I've had people that just take it to the x because they think this is 1 in itself. This is actually 2 times x to the fourth. So that's going to give us 2 to the 1 times 7, x to the 4 times 7 over y to the negative 3 times 7. Now, you don't have to do this step, okay? I do that to show what's going on, how we get from point A to point B, okay? So that was just going to be 2 to the 7th power, x to the 28th power, over y to the negative 21. And once you get here, that's not your final answer. Because we got something in there that cannot stay there, or negative. We can't have a negative exponent. So what do we do with our negative exponents to make them positive? You're killing me. We just flip it, okay? Now we don't flip this whole entire thing. The only thing you flip is that exponent. So I'm going to take that exponent, and I'm just going to flip it up here. And once I move it up there, it makes it positive. So it'll give me a final answer of 2 to the 7th, x to the 28th, y to the 21st power. Okay. So what we've done now is we've taken all of our rules that you learned last year, then we kind of went back over this year, and we apply them all right here in this one problem. Okay. And I've written them all up there. It's kind of like a reference too. Just so we see them, we're using them, right, and we kind of understand them. So exponent's the same as everything. It's just certain rules. You follow those rules, and everything can be that much easier. Product rule we add, quotient rule we subtract, negative rule you just flip it. Okay. Anything to 0 power is 1. All right. So let's look at another. We're going to look at one. This one's going to be a little more complex. Okay. So don't panic. All right. Let's say. Say negative 2 squared x to the negative 4th y over 3 z to the negative 5th. And all that raised to the negative 2 power. So when you do this, we can do this one of two ways to start. All right. You can go ahead and distribute that negative 2 to everything inside of there. Then start flipping everything. I didn't hate this. That's 2 days in a row. She been mad at me. I'm sorry. I'll get it. Oh, I'm so bad about that. I've been good. I've been doing yesterday. All right. So some of you would rather take this negative 2 and go ahead and distribute it, all right? And that's fine. Or we can flip to make this positive. But here's the thing about flipping to do that. If you flip this to make this positive, everything inside here doesn't change, okay? Because when you flip that, whatever's on the outside is changing. What was the inside is staying the same because we have not solved that yet, all right? So yes, that can get confusing. So my recommendation is let's go ahead and distribute this, then start moving things as we need to move them, all right? So take this -2 to everything inside of here. Now, this step that I've done here to show, you don't have to show that multiplication, okay? That's just a step to show what's happening and what's going on. So when I do this, I'm gonna have -2 to the 2 times -2 is -4. I'm gonna have x to the +8 and y to -2 over 3 to the -2, z to the +10. All we've done there is we've multiplied all these exponents. Okay, put that -2 there. And now we're gonna make our negative exponent positive. So you can think, try to sit there and think, oh, it's the reciprocal, I gotta flip it to make it positive. But an easy way to think about this is if I wanna make something positive, I'm just gonna move it from the top to the bottom, from the bottom to the top. Okay, this is the easy way to do it. So when I'm making these and making these changes, if I want these to be positive, I'm looking at my first two numbers. So if I want to make those exponents positive, I'm just going to move them. So I would have 3 squared, makes that positive. And then my -2 to the -4th, it ends up being -2 to the 4th power. So I'll flip those. My x stays because it's positive. My z stays because it's positive. And then my y is going to move to the bottom to make it positive. And that's going to be your final answer. Okay. So yes, it looks complicated, okay? But all it's doing is just based off our rules, okay? Every one of our rules. If you have to go like this to this step to here and just keep going all these steps, that's fine, all right? Because I know with exponents, it's very, very easy to make that small mistake, to forget to flip something, forget to multiply something, okay? It's very easy to do with that, all right? Question on this part? All right, let's take it one more. All right, let's say, let's have x squared, y to the -3rd, z to the 4th, over x to the 5th, y, z squared, and all that raised to the 3rd power. Now, if I use my order of operations, okay, can I simplify inside parentheses? Because here's what we need to understand with parentheses in here. If you have an x over an x, or we'll take all that up there, I can split all that. Because all that is exactly, it's just this right here. What rule do we have when we have division with the same base? We have our quotient rule, okay? Which means we're going to subtract. So yes, this is a lot in here, but I can simplify that by using my quotient rule. Because if I have my quotient rule here, that's just going to be x to the 2 minus 5. We're subtracting that. All right? So understanding that we can take this and split it with whatever like terms, and with exponents, like terms are like bases. Okay? So like my x, my y, my z. So if you want to simplify that to make that easier on you, right, do it, right? Again, you don't have to take these and write out x to the this minus this, okay? If I look at these two numbers and these two variables, I know I'm going to subtract these from my quotient, okay? My bigger x is on the bottom, which is my 5. So what is 5 minus 2? It's 3. So my 5 minus 2 is 3. 5 is bigger, so I'm going to have x to the 3rd at the bottom, okay? Y to the -3 and y. How would I make that -3 a positive? Where would I move it? To the bottom, and it makes it positive, right? So move to the bottom with y to the 3rd. Well, what's y times y to the 3rd? What do we do with those two exponents? we're gonna add them, because when I move that to the bottom, now it's y to the third, y to the first, you're gonna get y to the fourth power. And then my z's. Is my z gonna be in the top or in the bottom? In the top, that's where my bigger number is. And what's 4 minus 2? It's 2. And then all that is raised to the third power. So all I've done here is I've simplified that. Okay. Now, if that's confusing, can you go ahead and take this to everything? Yeah. Okay. This will make your problem a little longer. There's nothing wrong with that. All right. So now I take this 3 to everything inside of here. So I'm going to have z to the 2 times 3 over x to the 3 times 3, y to the 4 times 3, which is going to get me z to the 6th, x to the 9th, y to the 12th. So again, you could take this to everything on the inside, okay? And you can have all these big numbers, and you can subtract and go from there. That's fine. Right. Now, a lot of you wouldn't do that, and here's why. Because you're going to be so concerned how somebody else is doing it. Right. And I know I've told you guys, I'll sound like a broken record. Make math your own. Do it how you understand it. Okay? If that's the way you feel comfortable, that's the way you understand it, by doing it and showing all that work, do it that way. Okay? At the end of the day, our goal in here is for you to understand the content. Not for you to do it how I do it. Okay? It's for you to figure out, all right, how do I understand this? How does this make sense to me? Not, oh, I have to do it like this for you. Trust me, I've had teachers in the past that you had to do it their way or you would get points taken off. Right? And it's not fun. It's just not. Right? So, however you understand it, roll with it. Right? Roll with it. You might got any questions on any of that? I know some of that can be complicated because sometimes you can have those big long problems. But again, if we go to and break down our rules piece by piece, they're not that bad. Okay? Good. All right. Okay, let's get started on the learning today. We'll knock that out. That way.